Assalamu alaikum everyone. I am Sara Islam and welcome to our CSC 707 paper presentation. The name of our paper is A Comprehensive Study on Matrix Multiplication Performance. In this paper, we have analyzed the performance of matrix multiplication algorithm. So let's move to the introduction part of our presentation. We all know matrices are useful system for storing and manipulating data in computer science and electrical engineering. To manipulate this data, matrix multiplication is a very common process. That is why finding an efficient matrix multiplication algorithm is very important field in computer science. Many matrix multiplication algorithms have been developed for this purpose. In this paper, we have used three matrix multiplication algorithms, and they are NumPy, Eigen, and Stressen. We have applied this algorithm on different dimensions of square matrix and found that NumPy algorithm shows better performance on square matrix multiplication than other two in terms of both time and space complexity. That's all from me, and the next part of our presentation will be presented by my fellow groupmates. Thank you very much.
Assalamu alaikum sir. My name is Famna Jamal Labuni. In this presentation, my part is motivation. Now I am telling how this paper motivates us. Matrix multiplication and its specific variants are commonly encountered in numerical analysis. It is fascinating to explore matrix multiplication algorithms and in particular to understand under what condition it is feasible to outperform the easy implementation of the specification. The Stressen algorithm and general algorithm for matrix multiplication are discussed in this paper. In this context, it is expected that this will lead to the algorithm that overrides existing matrix and save a lot of memory, not allocating any new ones, if implemented correctly, which is very close to Stressen algorithm. Matrices were initially employed to solve systems of linear executions. Raw operations are just the pre-multiplication of the coefficient matrix by an elementary matrix. Some matrices are driven by a desire to succeed and respond positively to praise. Thank you, sir. Assalamu alaikum.
Hello, assalamu alaikum. I am Mohammad Shonur Rahman. I am here presenting the preliminary concept of this paper. Matrix multiplication algorithms come in variety of forms. There are several forms of performance indices for different algorithms. We will compare the CPU and GPU use of the Stressen matrix multiplication technique using two alternative libraries, Eigen library and NumPy library. Conventional matrix multiplication, the most common method for multiplying matrices in a conventional multiplication. Matrix multiplication is defined only if the width of the first matrix equals to the height of the second matrix. In Stressen approach, it decreases the number of multiplications necessary to compute 2 into 2 matrices. Stressen technique is likely to win the basic algorithm for n equal to 100. Eigen is a C++ library that supports linear algebra functions such as matrices, vectors, numerical solvers, and associated algorithms. NumPy is a Python package that is used to work with arrays. It has linear algebra, Fourier transform, matrices functions. It has tremendously powerful n-dimension arrays, very quick, adaptable, and indexing broadcasting principles are today's de facto array computing standards. Thank you.
Assalamu alaikum. I am Sumaya Ismail, bearing ID 212666027. I will be presenting the methodology part of this presentation. First, we will implement a naive version of Stressen's algorithm. Here the divide and conquer method is used, which is developed by Stressen, and it is widely used in matrix multiplication. We multiply matrices by putting them into the top left of a 2n into 2n 2n into 2n matrix. It is a very simple way of multiplying two matrices. This is inadequate in practice as we allocate tons of extra memory, and multiplying 513 into 513 513 into 513 matrix takes a much time. So we resort to standard matrix multiplication for small matrices. Here we can see the size of matrices are n by 2 into n by 2. There are 8 multiplications and 4 additions here. Now we will move on to dynamic padding and dynamic peeling. In order to use dynamic padding, we have several cases in our recursive step. If our matrix already has an even number of rows and columns, we do not need to do anything, as we can simply split it into 4 blocks. However, if the number of rows and columns are odd, we simply add another row or column. We initialize this row or column to zeros and perform the multiplication as normal. Once we have multiplied these matrices, we remove the extra row and column and return our result. Using dynamic padding keeps our logic fairly simple but avoids huge memory allocations and increases the size of our matrix. The implementation is also a very good thing of the dynamic padding. Dynamic peeling. An alternative exists to dynamic padding known as dynamic peeling. Instead of adding a row or column to make our matrix even sized, we instead remove a column or row. After performing the remaining multiplication, we account specially for our removed row or column. This requires a little bit of extra arithmetic, so the code ends up slightly more complex. Lastly, we have used Core i5 processor for the stress algorithm evaluation. 3 cores are used together here. Whenever we executed the codes, we run the code 3 times and took the maximum value that showed in the output. 2 libraries, that is NumPy and Eigen, were used as well. After doing all the works, the results are discussed in the result analysis section. Thank you so much for your patience. Assalamu alaikum.
Assalamu alaikum. I'm Mohammad Shaunur Rahman. I'm here presenting the result analysis. In this study, square matrices have been used with orders from 1000 to 6000. Execution time and memory have been noted for each matrix in order to understand the performance. When considering execution time, NumPy shows the best performance, whereas Strassen algorithm performed the lowest. In perspective of multiplication time or execution time, we can see that Strassen is taking the highest time, whereas NumPy is taking the lowest. In time of matrix multiplication memory, we can see that for 1000 dimension matrix and for 2000 dimension matrix and 3000 dimension and 4000 dimension matrix, and in the all number of dimension, NumPy has performed in the best and Strassen is taking the highest. So this is the result analysis part. Thank you.
Assalamu alaikum. I am Shah Sufyan Nur Mehdi. Here I am presenting the conclusion. The mathematical operation of computing a matrix-matrix product can be done in different ways. With Strassen's algorithm, we can improve the naive matrix multiplication for large matrices by lowering its complexity. While Strassen's algorithm may be faster than the naive algorithm, one needs to consider Strassen's recursive pattern while implementing it, which increases the number of allocations and therefore accumulating big rounding errors. Through this implementation in Julia, Volcker-Strassen's proof from Gaussian elimination is not optimal, as it is superior to the naive algorithm for large matrices. Thank you everyone.